See, these are the topics actually we have discussed in regular classes also. Mass logic, finite state mission FSM, MOS logic, NMOS, PMOS and CMOS logics. These two topics I will shift into the last portion, right? Only for ECE, ECE and instrumentation. I will give you some explanation and some expected question and models from MOS logic and FSM in the last half an hour. So up to last half an hour, this session is common for all branches. Only for the last half an hour, electrical students, they can leave. Okay? Right, guys. And electrical students, before going to the exam, you better to go through logic gates, mainly logic gates, and combinational circuits, adders, subtractors, multiplexers, sequential circuits, counters. These are the areas compulsory you must go through, right? And ADC and DAC resolution based questions, resolution based concepts, and whatever the questions that we have solved in the class, and PYQ, bits and bytes, or test series questions if you find. So you better to focus on those areas along with remaining all the subjects, all the topics. You better to focus more on these special areas. Okay, electrical students, okay, right. And let me start with a very basic, generally in every class, maybe live or offline, I used to start with a literal, variable, some terminology. So variable is okay, it is an alphabet intended to represent the truth values. But what is a literal? In a minimized Boolean expression, the available variables in the form of variables and their complements can be considered as literal. F is equals to a plus b bar. So there are two literals in that expression. Whatever may be the number of variables of this function, in the result if you find something like a plus b bar, there is no chance of minimization for this particular expression. Here a is a literal and b bar is a literal. So there are two literals. And here we are representing the variables. It may be a 2 variable function or 3 variable function, whatever. The entire function will be depends on these 3 variables like inputs or sensors or whatever, input lines. Right. Coming to the Boolean expression, just I have categorized these topics into some outlines like this. So the related data I will write, then it is easy to recall the concept. So sum of product form, product of summation, SOP and POS function. In SOP function, we can have minterms, you know. Minterms are also called as product terms. Products. POS is a function which is consisting of max terms. And summations, right? Simply I am writing sums. The function format will looks like this. F of ABC is equals to sigma m of 0, 1, 5, 6. This is actually standard SOP form. We can call it as sum of product SOP form, but it is in integer form. ISSOP also correct because it is integer form. Integer form. If I want to represent the standard SOP in an elaborated fashion, we should write it in terms of all variables. You know that 000, 001, 101 and 110. So that is a bar b bar c bar plus a bar b bar c plus a b bar c plus a b c bar, right? This is a expanded version of SOP, hence we can call it as a standard SOP. It is also standard SOP This is also standard. First one standard SOP in integer form. Sometimes we need the expression in integer form, sometimes we need the expression in expanded form. Sir, for example, there is certain expression f of ABC is equals to, here you see the example, f of ABC equals to, example, f of ABC is equals to AB plus C bar, sir. Sir, what is this function, sir? This is simply SOP. This is just SOP, sum of a product, that's all. SOP function. It is not a standard SOP. Standard SOP means either it should be in integer form or, strictly speaking, every term should consist of all the variables, right? So, this is a SOP and this is a standard SOP. This is a standard SOP in integer form. Similarly, POS. F is equals to f of ABC, you write, no problem. Pi m of 2347, some numbers randomly, 2347, or otherwise we can write 010, 011, 100 and 111, 7, right? So, we can write it as A plus B bar plus C dot so on. I am not writing. In POS, 0 should be assigned for a variable and 1 should be assigned for complement of the variable. But here 1 is assigning to a variable, 1 is assigning to a variable, 0 is assigning to complement of the variable. That is the main difference between SOP and POS, expanded form of expression representations, right? So, similarly, we can call it as standard POS. POS or standard POS. It is in the first one is in integer form, second one is in expanded form. That's all. Now, we can find two things here. Conversion. I am not giving you circuit example here. Okay. So, this is a brief idea. Every minterm combination will produce logic 1. For example, if you select only this combination, if all input sensors are 0, 0, 0, output will be 1. For occurrence of these combinations, this output F is going to set. For occurrence of these combinations, this output F is going to reset, output 0. Other than these combinations, output is 1. That's the main difference between SOP and POS. Now the conversions. Sir, I have an SOP function, sir. Sir, this is SOP function, sir. I want to convert it into POS. Conversion is different and complement is different. Don't confuse. Conversion and complement. While converting the function from SOP to POS or POS to SOP, we need to write missing numbers. A 3-variable SOP function can convert into 3-variable POS function and vice versa, right? So, while converting SOP into POS, we have to write missing numbers only. Just write missing numbers. So, ABC 2 power 3, it's a 3-variable function. There are 8 terms called minterms. So, out of our possible combinations, out of 8 combinations, 4 combinations available as minterms. So, whatever the remaining combinations, automatically those combinations will be available in its POS function, right? So, these are the max terms. This is what conversion. This is a conversion. This is a conversion. And next, complement. For example, if you take f of ABC, same function, f of ABC is equals to sigma m of 0156. 0156. If you take this function, you know converted function here I have given. No need to write it again. The converted function is like this. It will consisting of the missing numbers 0156, 2, 3, 4, 7 are missing here. Those terms will be available there. But in the complement, what do you mean by complement? In the lecture, we have discussed the complement just after logic gates. But here only I am giving you the complement information. For example, this is the function f. someone is asking you the capital F, if it is equals to F bar. That means what? After passing the function through one inverter, what is the output? That is the meaning indirectly. If you pass the function through one inverter, then what is the result? Right. So, while complementing the function, you should write the numbers as it is. But what is the difference? I am not giving you the proof here. Sigma m will be converting into pi m. Important, okay? So, what I am doing? Doing complement. So that f is equals to, I am assuming it as f of ABC whole bar. So, that is equals to pi m of 0156. Some students are writing again missing numbers here in complement. During complement, you don't write missing numbers. You write the numbers as it is. Only difference is sigma m will be converting into pi m. Sigma m here converted into pi m during the complement operation, right? So, we know the meaning of SOP, POS, general SOP and general POS, standard SOP, in standard SOP integer form and expanded form, and converting SOP into POS and vice versa, complement of SOP and complement of POS. If you complement the POS function again, you will get back SOP function with the same numbers. So, no sir, after complement I want SOP function only, then you do conversion. This is a complement result, okay? It is in POS form, pi m of something. If you want to get it in SOP form, then you write it, sigma m of missing numbers you write. That's the order we have discussed. Whatever may be the order available in material or textbook, this is the order generally I use in class. So, the same order I am giving, okay? Right. Next, now positive and a negative logic. You know, in the positive logic, high voltage, this is generally important for electrical students, okay? Be careful with this. Okay, positive logic, high voltage, generally we are considering it as logic 1, low voltage considering as 0. And the negative logic, reverse. High voltage should be assigned for the logic 0 interpretation of a computer. I mean computer or processor or register will accept it as a logic 0. And low voltage will be accepted as 1. Even the question is given for negative logic, you don't worry, just initially you ignore it completely ignore it. It may be a circuit, it may be a circuit, or it may be something like that, okay? Whatever may be that, just initially you try to ignore it. First you just focus on the positive logic. For example, just example, okay? There is some circuit. They are asking the question like one exclusive OR gate is given, one AND gate is given. They are asking the Boolean expression in negative logic. Output Boolean expression in negative logic. Then if you concentrate on negative logic, you will get unnecessary confusions. Unnecessary confusions. You don't give chance for unnecessary confusions. So, whatever the logical expressions that you know and that you studied, everything will be belongs to the positive logic. Do the problem in positive logic only. After completion of the solution, then you can convert, if requires, the positive logic answer into negative logic. Do you remember the technique we have discussed? We can convert positive logic into negative logic and vice versa, just by applying the duality. So, for example, you will get F naught is equals to A XOR B, XOR operation with AB. I am not simplifying it, okay? You do it later if you want. If you simplify this, for example, finally you will get F naught is equals to A plus B, China. You will get F naught is equals to A plus B, for example, okay? A plus B. What is this A plus B? General expression. He has given, for example, consider the circuit and find the output in negative logic, means by default whatever the circuits interpretations, everything we are taking in positive logic only, right? If you want to convert it into negative logic, you don't do like a ones and zeros complement operation, again expression, don't waste the time. Positive logic expression F plus is up, whatever the obtained expression you have, that is a positive logic expression, that is A plus B. To convert it into negative logic, just apply the duality. What is the duality? Do you remember? Actually, these are the very fundamental things, okay? So that's why I need to increase the speed slowly, right? So be ready to catch the speed. Duality and complement, two things we have discussed. Duality will obtain by interchanging ones and zeros and or operations. Literal should be as it is. But complement is little different, ones and zeros interchange and or operations interchange, but literals have to be complemented in complement form. In duality, literal should write as it is. Do not change the literal. So, A, you should write it as A only, B also you should write it as B, but plus operator should interchange as dot operator, so that this is the output of this circuit under which logic? Negative logic. Under negative logic. Like that, very simple. Okay, this is some basic information about positive negative logic. Logic gates using diode circuits. You know already after, during the digital, it's a different story now. You have been completed the preparation of all the subjects already. So you can easily understand. If you are giving excitation into anodes automatically, very simple. If any of the input is high voltage, output is high voltage. Any of the input is high voltage, output is high voltage. Then what is this? OR gate. Am I right or not? 1 plus anything 1. So given is a OR gate. If you remember some of these simple circuits like this, it is easy to answer the complicated circuit. And similarly, I have given another basic circuit with diode circuits, right? You can expect the same circuits but little different. Instead of a single diode, two diodes, they may give you n number of diodes by connecting them into cascading like. But if you good in fundamental, you can answer it. And they don't give you contradictory questions, you don't worry. VCC, remember China, logic 1 voltage, VCC voltage always same in any circuit. They will provide the data. Okay, they will provide the data, right? So that, for example, inputs are AB, inputs excitations are AB. We are giving excitations into cathode, okay, right? I have given shortcut for this also, right? If any of the input is 0, any of the input is 0, 0 means logic 0 indicates what? Low voltage, okay? By default, logic 0 means low voltage. Low voltage. What do you mean by low voltage? It may be 0 volts or it may be 0.7 volts, it may be 0.3 volts, whatever. All these voltages can be considered as low voltages. Logic 0. If any of the input is logic 0, automatically what will happen? The diode will forward biased. If this diode is conducting, simple, voltage at this point is nothing but drop across this diode. 0.7 silicon diode, 0.3 germanium diode. No sir, if it is ideal diode, sir, ideal diode short circuited. If it is short circuited to ground, what is the voltage here? 0. Okay, so that if any of the input is 0, output 0. Sir, if both the inputs are high voltages, are high and high, listen China, high means I assume 5 volts, okay? High voltage, that is logic 1. Logic 1 is nothing but high voltage. High voltage. So 5 minus 5, 0. These diodes are not conducting, so output will be 5. VCC means 5. So if both the inputs are high, 1 and 1, output will be 1. So given is a AND gate. Given is a AND gate. Right? So I am going to connect these circuits in a systematic way. Instead of asking you simple question, I want to give you this question. Can you answer this problem? Can you answer this question? The circuit shown the diodes D1, D2, silicon type, silicon, germanium, ideal, whatever, no problem. So find the output here. Here this is output node, Y0 is output. These are the dots, interconnections, okay, like this. Point number 1. What is the highest voltage in the circuit? 5 volts for logic 1. So highest voltage is 5 volts. 5 volts is the highest input. But these diodes, I will give you the numbers 1, 2, 3, 4, 5 and 6 diode numbers, okay. So the diode number 3 and 4, observe it. Whatever may be voltage at this point, in spite of that, this side 5 volts, even C and D values are 5 volts highest voltage, but cathode of this diode number 4 and 3 are already connected at very high voltage, that is 10 volts. So undoubtedly these two diodes are open circuited. Diode 3 and diode 4 are open circuited. Got it? Then you see this C and D, it looks like this, CD. There is some power supply. Again here also same. Of course, no need to reconstruct it. For explanation comfort only, I am just reconstructing the circuit. And from the same node, you see the common node, guys. See, this is another circuit. So you know already, this is AND gate and this is OR gate. Same thing. Even if you find n number of problems in this particular topic, you will repeatedly find the similar questions only. But by changing the circuit construction, they will try to confuse. So if it is AB and this is CD, output is, assume it is X and Y, output is X plus Y. What is the X? A plus B. And what is the Y? C plus D. A dot B, C dot D. Dot, okay? Dot. AB dot CD. Right? So because this is AND structure, this is also AND structure. A dot B plus C dot D. I am changing the screen. Similarly, we will do it with the transistors later, not now. Radix conversions. I don't want to spend more time on the radix conversions. In the radix conversions, we have discussed this entire topic into two phases, phase 1 and phase 2. In phase 1, standard methods and rules. Standard rules based operation. Phase 2, general conversions. General conversions. So what are the rules? Rule number 1. Radix value always should be greater than the symbol value. Highest symbol value in the system should not be greater or equal to radix. That means radix only should be greater than symbol. That is the rule number 1. And rule number 2, while doing arithmetic operation, if result is equals to radix value, then the final answer should be 0 with carry to the next bit position. Radix never be negative or 0. Another point. Radix always should be a positive integer. It should not be negative or a 0. Right? These are the important points. So from the standard conversions based on the radix value, or maybe like some examples. They will give you some number xyz plus something is equals to, they will give you the result. It is unknown. If you see the notes, we have solved some problems. And the recent gate question, actually 144 and 135 is equals to 323. Answer may be 6 or 7. Radix value, I think 6. We have solved in notes. But no need, I don't take it again those questions, those model questions. Just to recall the story, you just do the analysis with the standard polynomial. Any unknown convert into decimal, that is the meaning of standard polynomial. Automatically comparison will give you the answers. What is the value of x? And we have discussed some shortcuts also based on the rule number 1 and rule number 2. Majority of the cases based on the phase 1 concept, LHS, RHS comparison based or observation based questions are found majority of the times. So these type of questions are generally important for gate. And phase 2 general conversion, I don't know whether you remember or not. General conversion, like from the standard number systems, binary, octal, decimal, hexadecimal. Here we have developed some new systems, new radix, maybe base 3, maybe base 7. We have developed the conversion systems and new radix also, right? So you please, those things are generally for conventional paper. They don't ask you design a new system in a gate exam. They don't ask you like that. So generally here, we need to focus on the standard methods based comparisons. If you go through all the questions that we have solved in the notes, I will provide the short notes also. Already have provided short notes for all the students. No chance to miss the question model. Numbers may be different, but models are same. So that's why I am trying to recall the story. Now here, these are the available numbers or number systems. So totally we can make 12 conversions, 12 types of conversions. I have categorized the total conversions into 2 sets. First one, by taking the decimal as reference. Decimal to other radix. Decimal to other means decimal to binary, octal, hexa, 3. Other to decimal, 3. 3 plus 3, 6 conversions. Total there are 6 conversions. Here decimal to others. Let me take integer part here. Integer and fractional, maybe there are 2. Integer part, maybe fractional part. Here we are doing what? Subsequent division, or we can simply say successive division. Successive division. Quotient and remainder and given number, we will get something like this quotient and remainders from the last quotient number, whatever may be the value, to all the remainders in the reverse order. If you take, you will get the result in this new radix. For example, if it is 10 or 12, if you take 12 by, if you want to convert it into binary, 12 by 2. 6 times remainder 0, like that. I am not taking that silly examples here again and again. But what about the reverse conversion? For example, if you want to convert it into octal divided by 8, like that we will take the number. And the reverse conversion, others to decimal, standard polynomial, r to the power of n minus 1, bn minus 1 plus r to the power of n minus 2, bn minus 2 plus so on, r to the power of let me take 0 and b0, LSB. If you find a fractional part, r to the power of minus m, b minus m. Just by taking the bit position and positional value and multiply them, you know this. For example, 1100, if it is base 2, this is nothing but 2 power 0, 2 power 1, 2 power 3. This is not 2 power 3 is nothing but r power n minus 1. And 1, this 1 is nothing but bn minus 1 bit value. By taking the products, we are getting back. This is one set. Total 6 conversions. What is the other set? Binary to octal, binary to hexa, and reverse. Total 4 conversions. Here, this is the basic conversion. Basic conversions, not from systematic conversions, right? So, already available conversions. What I told you, 8 2 power 3 and this is 16 2 power 4. Take this 3 and 4 into reference. So binary to octal grouping. Binary to octal, you take 3 bits into single digit. So this side grouping, reverse. Octal to binary ungroup. Group and ungroup. Like that I have created the keywords. For example, if it is 6, you should write it as 011. 110. Like for example, if it is 6, okay, anyone can write. For example, if it is 1, you should not write it as single 1 or 01. Okay, compulsory you should write it as 001, 3 digits, because 8 is equals to 2 power 3. You have to group 3 digits from binary into single digit of octal, or a single digit of octal into 3 digits compulsory, single digit of octal into 3 digits in binary. This right to left ungroup, left to right is a grouping mechanism. So similarly, this is important generally for electricals. Be careful, instrumentation students also, they are asking these questions by link up with the multiplexer. I will solve some questions, right? Maybe some link up with some other logic gates also. I will give you that model, that is very important, you see. So actually octal to hexa, octal to hexa. So seriously, you don't go like octal to decimal and decimal to hexa. Better you do like this. Octal to binary is easy. Every digit in octal number should be represent or distribute with 3 digits in binary. For example, if you have 4, 100, like that, and this is a grouping. Look at this. Octal to binary, octal to binary is ungrouping, right? Ungroup. But binary to octal, grouping. But ungrouping means every digit should be ungrouped into 3 digits. But here you should take every 4 bits should be grouped as 116. One bit in base 16. Example, octal number, just assume that 3 and 5, just assume like this. Octal number 0 11, that is actually 3, and then 5 101. This is what binary. Octal to binary is over. Now binary to hexa, 1 2 3 4 bits. This is what I am telling you. Every 4 bits should be grouped. Sorry, excuse me. Right. So 1101. This is 13 D. And sir, we have only 2 bits left. No problem. Here you padding. We are doing just padding with zeros. So that 0 0 0 1. So this is simply 1. 1D in hexadecimal. Like that, even reverse case also. Like that we are doing this. So basic conversions in just 5-10 minutes, enough. Next, Boolean algebra. We are using this Boolean algebra as a just one method for minimization of the expressions. But sometimes some logical questions are asking from the Boolean algebra. We are using this Boolean algebra as a tool for a logic gates implementation, combinational and sequential circuit implementation, like that. Here, some standard rules, theorems and laws we have studied. Do you remember, man? See guys, idempotent rule, A plus A bar is equals to 1, A into A bar is equals to 0, A plus A is equals to A, and so on. Commutative law, AB is equals to BA, similarly A plus B equal to B plus A. If you want, you write, I don't write all, A plus B equals to B plus A. Associative law, A plus B plus C is equals to A plus B plus C. A of BC is equals to AB plus C. Commutative law applicable for all the gates, okay, all the gates except, do you remember this? Except not gate. I will do like this. All gates all gates, tick mark, accept the commutative law. A B bar equal to B A bar, A XOR B equal to B XOR A, like that. NOT gate, no facility. There is no possibility to check it for NOT gate. NOT gate is having only one terminal, right? So that NOT gate, there is no concept of applying this commutative or associative whatever. Associative law, AND gate, OR gate, XOR, XNOR follows. This question was given in electrical paper recent, okay? Be careful with this. AND OR XOR XNOR gates allows or follow associative, but remaining gates are not going to follow. NAND, NOR and obviously NOT gate also will not follow the associative law. Distributive law is a little different story. It's for combination of AND and OR operations, but actually here you know A into B plus C is equals to AB plus AC, or otherwise A plus BC can be adjusted as A plus B into A plus C. Generally this distributive law I very popularly using in every textbooks for logic gate implementation and POS function expansion. But generally in lecture, classroom lecture notes also you can verify. I don't prefer POS expansion by using this method. I directly use a K-map reverse operation. I use it to give the answer. But I will use this method. I have used, of course, I have given explanation of a NOR gate construction with this, in this structure. A plus B, A plus B into C plus D format is for NOR gate. Do you remember? A plus B into C plus D format is for NOR gate. If you find in this format, to convert into that format, you have to use this distributive law. Distributive and De Morgan's theorems will help us. Distributive law and De Morgan's theorems will definitely help us in the logic gates expansion, means like NAND and NOR implementations and simplification also. Okay, right. Consensus theorem and transposition theorem. Transposition theorem also help us sometimes in the universal gate design. What about this consensus theorem? AB plus A bar C plus BC can be resolved into AB plus A bar C. What is the transposition? You take this result AB plus A bar C. We can write it as A plus C dot B plus A bar. And important, De Morgan's theorem, A bar plus B bar. Sorry, right. A bar plus B bar. 2 NOT gates and 1 OR gate. Instead of 3 gates, we can do it with single gate. AB whole bar. It is a theorem. If you want, utilize it, otherwise leave it, no problem. It is a type of adjustment. Similarly, A bar dot B bar dot C bar, we can write it as A plus B plus C whole bar. A plus B plus C whole bar. Right? So redundant, very, very important. Even in short notes also you can find the problems. In our notes, 50% of Boolean algebra based questions are solved based on RLR. Without RLR also we can solve the problems, but with RLR you can skip so many unwanted intermediate steps. So many unwanted intermediate steps, okay? Right. So what is that? Please be focused. Everyone knows this. A plus A bar B can resolve into A plus B. A bar plus A B bar can resolve into A bar plus B bar. But for so many students, I have given this advice so many times. Even in regular class also, I used to raise this line so many times. Do not by heart the formula A plus A bar B equal to A plus B, like that. Understand the format. Understand the format. What is the format? See guys, A plus A bar into something you should read. So students are actually, for example, if they get like this A plus A bar into C bar, they are unable to solve. 2024 gate one problem, logic gates based XOR link with XOR and AND gate, 2023 gate, I'm sorry. Okay, this is one intermediate line in the solution. So many students confused. Sir, how did you write A plus C bar? A plus A bar into something. If you read like that, you can understand it. I am not giving the proof here in this short span of time. I cannot give the proof. A plus A bar B equal to A plus B. Generally, students will read like that, but you are the professionals, okay? You read it like a pro. A plus A bar into something is equals to A plus something. You read it as a pro, okay? So it is A plus what is that something C bar. In place of B, even it may be a expression also. You write that expression A plus A bar into something is equals to A plus whatever may be that something. Maybe B or B bar or C bar. But sir, in textbook given like this? In textbook given like this only. That's why I am telling you that. Right? And similarly, here also, listen my dear friends. A bar plus A into something. It may be B bar or B or XYZ. I will do one thing. A into XYZ. Then what is answer? A bar plus XYZ. That's all. Okay. A plus A bar into something is equals to A plus this something you should write. But students, generally it's quite common, because as these relations are provided and highlighted, automatically we will by heart A plus B, A bar plus B bar will come right side like that. But that is not the way. A plus A bar into something, A bar plus A into something, you write like that. Got it? Okay. Now, actually no need, okay, this is intentionally I have given, maybe covered in class generally. I don't miss this model. There are so many models here. Instead of focusing on direct taking the function, taking common terms minimization, this is one example. In the logic equation, has given something that is equal, entire function value is equals to 1. If C equals to A bar, then what is the option? My dear friends, examiner is saying that he has given some relation of internal variables. C is equals to A bar. So what should I do? Do I want to replace C with A bar or otherwise A bar with C? There are two chances, right? Most of the times they don't give you this kind of questions for 2 marks. And for 1 mark, they don't make complications. Definitely they will give you hint. I think 2 times this model, exactly 2 times. This is first time, next XYZ in terms of X and X bar, something like that. In both the cases, examiner provided hint in the question. You have to observe it carefully. If you observe all the options carefully, AB, in terms of AB, the options are available. That means what? C and C bar have been eliminated. In the expression, C and C bar have been eliminated. How, sir? Very simple. Wherever you see the letter C, you write C bar. A bar. That means in place of C, you write A bar china, and in place of C bar, you have to write A. Then problem solved. Okay? Very easy. This is C. In place of C, you should write A bar, okay? You should write A bar. Then tell me A plus A bar. In place of C, you have to write A bar. Inside the bracket, we have A and A bar. A plus A bar, 1. A plus A bar, 1, okay? 1 into A, so that first result is A. Plus, see guys, in place of A, in place of C, you can see this. In place of C, you can write A bar, okay? So, this is also A bar. A bar into A bar, A bar plus A, 1. This is totally 1. 1 plus anything, this is 1. Similarly, in place of C bar, what can I write? In place of C bar, you can write A. C bar replace with A, na? A plus A bar 1. So totally this is 1. 1 plus anything 1. 1 into 1 into B bar. This is B bar. That's all. What is that? Is equals to 1. So A plus B bar is equals to 1 is the result. Right? They don't give this F equal to, just function equal to 1 is actually available in the paper. Got it? Right. So based on the options, they will give you the hint, but we have to sense it. We should go and observe the question carefully, right? We should go through the options sometimes. For some types of questions, especially in digital electronics and even in EMF also, some subjects, you can find the hint for the problems in options. There will be some similarity in the option that should be considered as what we call data, right? Examiner don't provide the data directly. I have shown that kind of things for state diagrams for EC students. If you observe 2012 gate problem, one multiplexer followed by what we call D flip-flop. D flip-flop followed by multiplexer, question was given, state diagram. No data provided, everything is provided in options only. Like that, there are some special cases you need to observe the options. From the options also, sometimes we can get some data points. The student who sends the data points, they can get definitely the quick answer. Okay.